All right, hi everyone. Hope folks are doing well today. So yeah, I'll be doing a little live stream here talking about some audio programming things. Let me fix my audio here. I've got a little echo happening. All right, hopefully people can hear me okay and whatnot. All righty, there we go. Cool. Yeah, so today I'll just be talking a bit about some plugin development that I've been working on. This is for a new plugin that I started on a little bit ago. It's called Chow Multi-Tool, and sort of the idea here is that it's supposed to be kind of a mixed bag of a bunch of random kind of signal processing utilities that I found useful. I actually started a bunch of them as kind of example plugins for some of my DSP library that I was working on. And then I started using them more and more often. So I figured I'd try to make them into a more polished plugin. And that's kind of, yeah, where things are at right now. So I guess to start, I'll just show everyone where the plugin's at currently. So I'll build what I've got so far. Yeah, so this is going to be the clap plugin target, but we've got audio unit and VST and everything else as well. And yeah, I guess something that I've been doing is trying to experiment with some different ways of doing things than what I usually do with making a Juice plugin. So maybe I'll show some of those tricks as well, some things that I've been working on. So let me move the camera so I can see my screen all the way. All right, can you all hear me on the stream and everything? Audio's good and everything. Okay, it's taking a minute to compile here. Interesting, that seems a little slower than normal. Anyway, I'll get things set up on this side as well. Cool, all right. Yeah, so I guess while this is compiling, I'll show you guys sort of the way that I've been setting this plugin up. So this is using sort of the new plugin state management stuff that I've been working on. I showed this in a previous talk that I did for the Audio Programmer YouTube channel. And so basically the whole plugin state is managed in this plugin params object. And then down here, we've got all these parameters that correspond to each of the individual tools. And then I've got this plugin state implementation here, which is then the template argument for the plugin class that we're creating up here. Oh, Josh is saying I should change my name in Zoom. Let's see if I can figure out how to do that. Not sure. Yeah, I'm not sure. Maybe Josh has an idea of what's the best way to do that. Oh, rename, perfect. Cool. All right. Yeah, sweet. So this is almost done building. And then we can show everyone how it works in the DAW. A couple other things I'm doing differently is I've got these parameter version hints. So this is something that's new-ish with Juice 7. And oh, actually, I've got a new way of doing this that I haven't brought in yet. Let me make sure that my submodules are up to date. Oh, hey, Jamie. All right. Yes, this is something that I've been doing a little bit recently, is trying to figure out better ways to handle plugin versions. So let's see, I'll do using namespace. I have this include here. So you've got version string literals. Hopefully the include for that works out. Then we can do, so this is version 1.0.0. And then this is just a little string literal suffix telling the compiler this is a version. I think I'm going to need to rerun CMake and everything to get the red lines to go away, but then y'all can see that. Anyway, I'll since this finished building, I'll install that and run it while I build it again, so you guys can see that. Build again. Anyway, yeah, so let's load up the plugin here. Cool. Yeah, so this is the plugin. When you first open it, it's not really doing anything, but then you go in this menu and you pick basically what tool you want. Okay, yeah, let's make the font a little bit larger as well here. Let's see. I don't think I'm in presentation mode, but let's just make this font maybe 20. Well, that didn't really change the editor font. Maybe I had to do that here. Yeah, okay. Hopefully that's a little better. Cool. So anyway, back in here. Yeah, so this is the EQ. And so right now there's not really a UI for it. It's just these parameters. But I'll pull up the EQ analyzer. If anyone doesn't know this plugin, you should definitely get it. It's Burton's EQ curve analyzer. It's totally free. I think you can. I think you have some other plugins that are paid, so definitely support the developer if you can. So you make some really cool stuff. But yeah, so we can just see the EQ basically. So you got your high pass filter, you've got all your other usual filter bands. Oh, something's a little off here. It says hertz instead of dB. I gotta fix that. Anyway, but yeah, usual EQ kind of stuff. So yeah, at some point I'll work on a UI for that. And then you got your, I think we're doing 8 bands here. Maybe I'll make it flexible so you can do a different number of bands. And then there's a linear phase option as well, which is kind of fun. But yeah, so that's EQ. There's a wave shaper, which also doesn't have a UI at the moment. For that one, maybe we can do a little test tone kind of thing. So if I put a sine wave through it, and then I put an oscilloscope after it, there's oscilloscope. I always want Bitwig to make these things wide, and I always have to do that manually. But anyway, yeah, so we've got kind of a regular, like tan H kind of wave shaper. I'll scale this a little better so y'all can see that. So yeah, it's just a regular tan H. We've got hard clipping. We've got cubic soft clipper. This is a 9th order soft clipper. Maybe I'll lower the frequency so you can see a little bit better. Yeah, so it's kind of hard to see the difference. Maybe Spectrum Analyzer would show it a little better. Yeah, I'll make that one wide too. So yeah, 9th order clipping versus cubic clipping. Yeah, a little bit difference in the spectrum. And then got a rectifier. So that one's pretty, that one makes a pretty big change in the signal. And then a couple of wave folders, which are pretty fun. And yeah, so that's the wave shaper. Then there's a signal generator, which is basically the same as the test tone thing in Bitwig, but you know, anyway, so I've started working on a little UI for it. I don't really like it yet, so I haven't put too much effort into making it look good until I decide exactly what I want to do with it. But yeah, so right now it's just a spectrum and a way of choosing the wave that you want. And then there's this Pultec EQ. Maybe I should bring back the EQ curve analyzer for this. Yeah, so this is kind of a circuit model sort of thing based on the old Pultec EQ circuit. So you've got some bass boost and bass cut, and you can pick your bass frequency, change that around. Oh, I think I've got these. Well, yeah, I think I've got these labels incorrect, but I'll fix that. And then, you know, similar thing for treble cut and treble boost. And then the treble boost actually has a resonance, you know, make it more obvious. Resonance parameter that's kind of fun. So we can make that filter a bit more resonant. So yeah, that's the Pultec EQ, which also needs a UI at the moment. And then there's this band splitter, which here I'll show it. It's the right way to show it here. Probably Spectrum Analyzer. So we'll do white noise. It also does this thing where it gives the spectrum a ramp, so I'll get rid of that. But yeah, so right now it looks like the band splitter isn't doing anything, and that's just because it's a multi-output plugin, so we need to tell the plugin which output we want to look at. So let's see. Maybe this isn't working quite right either. Maybe I need to fix this as well. All right, cool. So we've got a few things to fix here. So let's just put some notes together here. So I'm going to work on EQ gain label is wrong. I think the Pultec bass frequency labels are wrong. And then it looks like the band splitter multi-output is not quite working right. So maybe those are a couple things to work on today. And yeah, I kind of wanted to look at the band splitter anyway, so maybe I'll start with that one. Cool, let's see if I can get this to work correctly. Oh, right, I changed the name of this namespace here. So virtual literals, there we go. And then make this auto. Let's see, I'll do get version int, and now we know that's an int. So yeah, I guess this probably isn't very self-explanatory, so I should go into a little more detail on this. So basically, I had gotten a little bit annoyed at managing Juice plugin versions. So I worked out a little module here that I've been using for sort of managing this in a slightly better way. So kind of the way that Juice hard codes your plugin version is in this Juice plugin version string, which if we look at it, well, I guess I can't expand it right now, but it's going to look something like that, basically. And this is just something that the producer will define for you, or the CMake configuration will define for you. So basically what I wanted to do is come up with a little bit nicer way of dealing with that. So I made this version class, and so what you can do is take a version string or string view or whatever, or 3 integers, and you can make that into a version. And basically the version is just 3 integers. So you've got your major, minor, and patch. Maybe I could make it, int 8 or something, but it's probably fine. And then you've got some operators to test equality and greater than or less than or things like that, which is kind of handy. And then you can also get a version hint. So this is handy for the Juice 7 parameter IDs. And so the way I do it is basically say, okay, you can have 99, or I guess 100 patch versions, 100 minor versions, and 100 major versions, and you'll never get a conflict, which seems to be good enough for anything that I've needed so far. And then this is kind of a handy thing that I really like with, I think this is C++ 17, where you can do this string literal. So if I give the compiler a string literal and then this _v after it, then it will basically use this function to convert the thing into a version. And so that's what I'm doing here with this 1.00 _v. So yeah, just a little kind of handy thing to make things look a little nicer and hopefully a little more readable. But yeah, so let's start with the band splitter now. Band splitter. All right. So for this one, I've had to do things a little bit differently than I've been doing for most of the processors here. So yeah, I guess another thing that I'm doing a little bit differently from most of the plugins that I make is that I've been trying to do as much as possible at compile time, which has been kind of a fun, but also not the easiest process. So all of these, I'll just show you all here. All of the tool types are basically in this types list object. So this is a list of all of the tool types. So I've got my EQ processor, signal generator, everything. And this is a type, so it's compile time construction. And then this types thing basically creates a tuple of those types. So I've got all my tools here, and they're in a tuple. Sorry, that's a little bit of a tongue twister. And then whenever I want to process a buffer with one of the tools, I can use this visit at method to basically get my tool here as an auto type. And then here I'm saying, okay, this is the band splitter processor. So I know I'm going to have to split up the incoming buffer into these different buses, and that'll give me my input buffer and my low buffer and my high buffer. So yeah, let's see maybe what's going on here. So let's see if I can debug this a little bit. Yeah, so one thing I really like about Bitwig is that it's fairly easy to debug my plugins. So I can just attach the debugger in CLion to the plugin hosting process in Bitwig. And there we are. Okay, cool. So we know we're looking at the band splitter processor. And then if I do, okay, get bus count is not equal to 2, then return. So let's look at this again and see what happens when we actually look at the bus count. So we're looking at the output bus count. I wish that was a little bit more of a descriptive argument, but that's okay. All right, and I guess we've got to dig a little bit deep here into audio processor. So we want to look at output buses. Values, okay, and it looks like output buses is 3. Okay, so I'm not 100% sure that that's what we want. Well, let's pretend that it is for now and see if we can get that to work. So where were we here? So let's change this to 3 and try to rebuild. Oh, hey, Matt, how's it going? Yeah, I guess while we're waiting for this to build, does anyone have any questions or anything so far? Anything you'd like to see a little bit more about how it works? Get some water as well. Turn on some light also. The build seems to be going a little slower than usual. I wonder what's up with that. Okay, yeah, so maybe Zoom is using a bit more memory. Okay, yeah, that's probably part of it. That's okay. Anyway, let's quit that. Cool, there we go. So let's bring this over and see if that works now. So basically what I'm trying to do is make this band splitter set up so that basically you can hopefully fairly easily do some multi, like if you have a drum track or something and you want to do some plugins on the low band and some plugins on the mid band and stuff like that, then you could just use this band splitter plugin to split this into multiple tracks or multiple outputs or however you want to do it. And then use that for sort of doing a multi-band mixing strategy or something like that. So yeah, let's see. So we've got, looks like this is working, and we've got a minus 12 dB slope. So that's probably about right. Yeah, so we can see that this is correctly doing these outputs, and then main is just the usual output here. And then let's see if we can do our slopes. Cool, yeah, so that's our different slopes or things like that to make the crossover a bit more steep or a bit more shallow, depending on what you might want. And yeah, that seems to be working out. And then let's just make sure that if you add them up, then you get back to your 0 point. That looks about right. Maybe it's a bit, it's a little bit loud coming out maybe. So maybe there's a bit of gain being added or something like that. So we might need to compensate for that in some way. Interesting. Huh, okay. Yeah, maybe that's just something to do with how this splitting thing works in Bitwig. I haven't really used it a ton. Or maybe that's also something that has to do with the filter slope. Yeah, I know my voice tends to be a little bit low. I don't know why that is exactly, but I don't know. That's just how things tend to go for me. So yeah, maybe an exciting thing to do now would be to work out a UI for this band splitter and see if we can knock that out in the next little bit. I think that'd be kind of fun. So yeah, let's work on that. So let's close up some things here and go to our GUI and look at the band splitter editor. So yeah, I think I'm going to do something kind of like with the signal generator, at least for now, where it's got like sort of this plot area and then like a menu box below that has the options for the different slopes and things like that. So yeah, let's start with that maybe. Okay, so we no longer want that, and instead we'll do a similar kind of thing here. So this will be choice box. Yeah, maybe we should have some options as well for how to do the multi-output. So maybe you can solo just the low frequencies or solo just the high frequencies or something like that. But I'm not totally sure what's the best way to do that at the moment. So I'll keep thinking about it. And then let's see what else we were doing. So yeah, the fill all was just to kind of make sure that I have the right components. So maybe I won't bother with that right now. Cool. And then yeah, I'll do something similar with the resized function here. So come back to that. We'll add and make visible the slope choice box, and then I'll need to make the parameter attachment. So this should be slope choice attachment. Slope choice. Slope choice attachment, and then this should be the parameters, the slope parameter and the plugin state. Do I need something else there? Oh, I need the menu box, of course. Yeah. So let's see. I need the reference parameter, and then slope choice box, and that should do it. Cool. So now let's work out a plot component for this as well. So we'll call this band splitter plot. And we'll make a CPP file for that as well. All right, and then I'll add this to the CMake configuration as well. So band splitter editor, and then we've got band splitter. Cool. And then we'll reload the CMake configuration. All right. Cool. So for this, what I'm thinking of using is this new-ish class that I've been working on. So I've got this little visualizers module that I started on a couple weeks ago, and I think I'm going to do an equalizer plot. So it's kind of a few choices for this here. So let's see. Well, I don't really care about the CPP file for right now. Yeah, it's a lot of stuff in the header file just because there's kind of a lot of templates in some places, but maybe we don't need to use those exactly. So let's see what we got here. All right, so this is basically going to be like a 2-band equalizer essentially, because we've got kind of the 2 filters in the band splitter. So let's think about how we want to do this. So this will be a new class. I'll just include PCH for now. This band splitter plot. And we're going to make this be derived from equalizer plot. Oh, forgot the I'm not getting IntelliSense for this. Maybe I'll try to add it here. Let's rearrange that. All right. Cool, so that looks like something. Public. This have the juice leak detector. Declare valuable detector. Cool, and then I'm gonna need a constructor for this as well. And I'm definitely gonna need the parameters. So I guess I'll just pull in this include from here. Actually, maybe I'm gonna need the state as well, because I'm probably gonna need a parameter listener to make sure that I know what to do when a parameter changes. So I'll just pull both of these over and pull these arguments as well. Let's just go ahead and create an instance, and maybe we'll get some red lines for things that I'm doing wrong. And we'll just call this, I'll do the full name, band splitter plot. So let's see here. And splitter plot, I'm just going to have a plugin state and params as its argument. And then here we'll do plot. And here as well. Yeah, and then let's just paint some things to make sure that we're getting everything on the screen that we want to have on the screen. Oh, it's not happy with equalizer plot. Okay, sure. All right. And let's put a little bit of the CPP file here. Come on. And then we'll just put together a little constructor here. So for now, I'll just paint a color so that we know what we're getting. Choose colors red, something like that. And then for this, I'm going to need to initialize the base class. So I'm going to need this bands and this spectrum plot params. So let's see what we got here. Okay, I'm going to have a name conflict here. So I'm going to rename this to be a little more exact. And so let's see. Q equalizer plot. So this is going to have two bands. And I guess I could do the default parameters, but actually let's take a look at this so that we know what we're getting again. Yeah, so for this, we want to set some minimum and maximum frequencies and magnitudes. So let's decide what we want here. So I guess I'll need to name this ChowDSP spectrum plot params. And then we'll do with our minimum frequency, I think 20 is probably fine. And then max frequency, maybe 20K as well. Well, let's see actually what's the range of that parameter. So we've got okay, it's 20 to 20K. So maybe I'll give it a little bit of extra room, just so that we can see kind of where things end. So I'll make this 24 and I'll make this 10. And we can always tweak that later if we want. So we're probably going to want the bottom magnitude to be something small. I'll do minus 60 dB, and then max magnitude, I'll do something kind of low again. So the idea here is that the sort of flat part of the frequency response is going to be at 0 dB. So I've got a little bit of extra room above that. And then we're just going to go pretty far down. Maybe we want to go further, but I'll just start with that for now. And then, yeah, let's leave it at that for now. Although maybe we want to have like an update filter plot path here. Yeah, so let's set up our parameter listeners too while we're at it. So let's just go ahead and do plugin state.add parameter listener. And so we want to listen to all of the band splitter parameters. So yeah, we'll do slope. And I guess we want a reference, so we'll do that. And then we want parameter listener thread. This should be on the message thread. And then I guess we need our listener, which is just going to take this as a capture and no arguments. And then we just want to do update filter plot path. And actually, you want to update all of them. So I'll do band index, just to give it a more descriptive name. Band index is less than, I have a num bands kind of thing. Well, maybe I should add that. So for now, I'll just do 2. Well, I'll just make that a constant up here. Put that in a space. So bands, and then increment band index. Did I do that right? I think so. And then band index. And actually, we're going to want to do this for other things too. So I'll move this into its own little lambda here. Plot updater. And then here, I just need to capture, well, I guess I should capture by copy, right? Plot updater. We'll just run plot updater. And semicolon after that. So now let's do the same thing for the other parameters. So cut off. Yeah, and then we've got a little problem here, which is that we want to do something with the scoped connection that comes back from this. So I'll just do I think this is like a callback list, scoped callback lists. And we'll call this callbacks. And then let's see if we can make this a little bit nicer, actually. So let's do const juice ranged audio parameter. And so let's loop through. We want band splitter params. The autocomplete this, is it? Anyway. And then splitter params. Cut off. Oh, I know why. Because I didn't give it a name. What's going on here? Conflicting types. I guess I need to cast these. Well, Okay, yeah, that'd be a bit annoying. So let's not do that. What I was trying to do is do a for loop that goes through all my parameters, but I don't know. It seems like maybe there's no way to do that. No way to do that. That's particularly I don't know, easy. So maybe I'll do a for all parameters instead. Well, yeah, it can be const. Okay. For all parameters. And so we'll do block updater as a capture. And then we want a const auto param, and I think I need param index as well. And then I can do this as a thing in here, hopefully, and this would just be star param. And then I also need to capture the state. And now the problem is just that our listener is kind of dangling here. So I'll capture this as well. And then I can do the callbacks plus equals this. And I think that should be okay. I don't need a semicolon there. Cool. So I think that should work. But let's check that here. So first we want to make sure that the red is getting painted, and then we want to make sure that plot updater is getting called whenever we change a parameter. So yeah, let's do a little test on that. All right, yeah. Well, it's building again. I guess if anyone's got any questions, I'll talk about things. Oh, all right. We've got an issue here. Oh, I did a spelling mistake. Fair enough. All right, and then we've got indirection requires pointer operand. Oh, okay, this is already a reference, so I don't need to double dereference that. I think that should be a little bit easier now. All right, cool. Yeah, looks like that's going to compile. So let's go ahead and copy that into Bitwig. And yeah, let's see here. After it starts up, then I'll attach the debugger. Okay. All right, attached, and cool. So we've got our red plot area being colored in there, so that's good. And then let's go to the band splitter parameters. They're probably kind of far down here, and let's make sure that our breakpoints get hit. So if I move this, oh, looks like it worked. Where'd my mouse go? There it is. Okay. Yeah, so our breakpoint gets hit when we change the, I think I changed the cutoff parameter. Yeah, cool. And then let's try that again with the slope parameter. So that was cutoff. And then if I change slope, awesome, cool. Yeah, so that's kind of a nice proof of concept that our listeners are getting hit. And then maybe let's test again by making sure that if we close and reopen the editor, that all of our listeners are getting deleted and recreated properly. So yeah, we're not getting any crashes when we start moving these parameters after closing and reopening the editor. So that's kind of nice. Awesome. So now let's think a little bit more about what we want to actually have painted in the plot. So kind of the idea here with this spectrum plot params and equalizer plot and all of this is that I kind of wanted an easy way to draw like a frequency domain plot. So typically we're going to need our like lines, our lines that go across sort of the different frequencies and across the different magnitudes. So for frequencies, I've got this draw frequency lines thing. So let's see how we want to do that. So I could do draw frequency lines, and for this we'll do maybe just a plain white for now. Well, this could get a little messy with colors. Let me see what colors we've got going on now. Yeah, and all of this stuff is not going to look good right now. So, you know, we're going to have to, after all of the things are in place, maybe I'll talk to some designers or something and see about making it actually look good. But for now, I just want to make sure everything's visible. So I think what I'm going to do is I'm going to recolor sort of the background. So instead of black, it'll be, I don't know, like blue or something, or gray, or I don't know, something neutral. And then I'll go ahead and make the plot background be black. So let's do some repainting here. Oh, that's not right. So let's take that, implement it here. So yeah, let's fill with, I don't know, what's a good color? So like a blue-gray kind of color. Blue-gray, no, I don't know, I kind of want blue, but I don't know. What's the right color to have there? This Juice's Dodger blue is not too bad, so maybe I'll just do that. And then here, I'll do, first we'll fill all with, my typing is not very good today. With black, spell that correctly. All right, so the plot background will be black, and then the frequency and magnitude lines will be white. So let's see, what are our arguments here? So we need our G, and then we need a bunch of frequencies that we want to draw at. So I'll do, let's see, well, I think what I'll do is I'll do thicker lines at 100, 1,000, and 10,000. And then what else do we got? Line thickness. So maybe I'll do like thicker lines here. And then I'll do other lines that are thinner. So the thinner lines will be like 20, 30, 40. Yeah, it's gonna get a little bit annoying. Let me just try it like this to see what it looks like, and then we can automate the process of actually generating these lines in a little bit. Yeah, so let's see what that looks like. And then let's also have a few magnitude lines. So let's see, we're going down to -60. So maybe I'll start at -50. Like that. Sure, yeah, let's give that a try. Maybe we want to go by like 12s or something instead of by 10s. Let's just see what we get. Yeah, I'm supposed to get a couple of electronic parts coming in later today as well. So I'm kind of excited for this package to come. So whenever I hear a truck drive by, I look up and get excited. But anyway. Yeah, so let's see where we're at with this. Okay, that's not too bad. Maybe it's a little bit busy. Yeah, maybe I'll make these minor lines like a sort of gray for the frequency axis, and then for the magnitude lines, I don't know. Let's see what Bitwig does here. I guess they do everything a little bit more gray or something. Yeah, I don't know. I'm not totally sure what to do there. Yeah, interesting. Okay. Well, I'll just leave those as is for now then, and think more about what we want that to look like later. And in the meantime, I'll try to get the actual filter plots to be working out. So what we're going to want is sort of a distinction between the different slopes and how that corresponds to the EQ parameters and the different filter types. And then I guess we probably want them to be active always. I think they start out as being inactive. Yeah, most likely they start out as being inactive. So let's do this. Yeah, well, I don't know. Maybe I got a little too fancy here for my own good, because I might want to undo some of that now. Yeah, that'll teach me not to prematurely optimize next time. So let's see, maybe here we want to do set filter active index is true. So this will basically tell the plot that both filter bands are always active, right? And then let's see, so yeah, I think I got a little too fancy here with some of this stuff. So let's adjust this a little bit. So first we want to do the cutoff parameter. So when the cutoff parameter is changed, what we'll want to do is just change the frequency here. So we'll want to do, I guess we'll want to capture this, and we'll want to do set cutoff parameter. And this will be band index, and this will be the cutoff param. So I can capture this maybe with a bit of a name here. So see if I can do that. And then cutoff param. I can do that. Cool, yeah, so I think that should get me more or less what I want. And then I'll want something similar for the slope parameter, but it'll have to be a little more, I don't know, maybe a little bit more, like there's a little bit more to do here, I guess is what I'm saying. So I guess band 1 will be the low pass, filter, and band 2 will be the high pass filter. So let's see how do I want to do this. So I'm going to need to do set filter type, right? And then I'm going to need to also do set Q parameter. Right, so these two functions are going to need to happen somewhere in there. maybe I'll do this because I think the Q parameter, if I remember right, for a crossover filter, the Q parameter is always going to be a half. I might be wrong about that, but I'll fix that later if it's wrong. And then I'll have a little getter function. So this will be get filter types. And this will be a lambda as well. So we're just gonna have lambdas inside lambdas here. And so this will be, let's see, well, let's see how I defined it here. So I've got this enum for slopes. So I can probably just get the enum value and like switch on that or something. So let's see, slope equals slope param dot get, and this will get me the actual slope that I want. Reformat that a little bit. All right, and so we'll switch on the slope. And so if we've got slope, well, this is inside a namespace, isn't it? Yeah, this is in DSP band splitter. So let's just pull that in as well. Slope. If it's that, then we'll return. Well, let's see, how do I want to do this? So I want to return these filter type things here. So we'll have LPF1 and HPF1. So I'll return these as a pair. With std make pair. I guess I could do like a make tuple instead, but it's probably not that big a deal. Let's do a couple of usings here just to make things look a little nicer. So band splitter, oh, that's a lowercase, band splitter slope. And then using ChowDSP EQ, I think it's filter type. I don't want a second using there, do I? What's the right name for that? EQ plot filter type. Cool, and that way I can just make it slope and then EQ plot filter type. This will be LPF1, and I'll do, whoops, I'll do second one for HPF1. Cool, and then we can just do a similar thing for all of the others. So let's see, we've got 12 dB, so this will be LPF2 and HPF2. I think I've got 18 dB as an option. No, 24 dB. Yeah, so that'll be LPF4, HPF4. I think I did 48 and 96 as the others. So this will be, what is it, LPF8, I guess. Is that right? Or is that, yeah, I think that's right. And then 16, do I have LPF 16? I do not. Okay, so I'll need to be a little bit more clever about how I do this then. So, well, I'll just do LPF 12 and stuff for now, and then I'll fix that later. Since I think that's going to take a little bit more effort, and I just want to see if I can get this to work more or less. So let's do, we'll put these in a, here we call this, this bracket things. This is a low band filter type and the high band filter type equals get filter types. And then I'll do set filter type for the two bands. So 0, the low band filter type, and 1 will be high band filter type. Cool. So yeah, let's try that. So now we actually need to plot those. So I'll just plot these in red for now, just to make them very, very visually obvious. Set color, okay. And then I'll do, let's see, I'll do stroke path. And, get path, there we go, get path 0. And then this will be, I think it's a path stroke type. And I'll do thickness of 2 again, just to stay consistent with the others. And then same thing for the other types. So yeah, let's try that, see how we're doing. Yeah, so I guess we're doing a little more UI stuff today than DSP stuff, but probably to be doing a little more DSP in the future here. I've got a few other things worked out. Okay, so we've got an unused variable. That's probably fine. I'll get rid of that later. Yeah, let's just get rid of that. I don't think we're going to need that. Anyway, let's see what we've got now in the UI for the band splitter. Okay, so clearly not exactly what we want. Interesting. Okay. Interesting. So it looks like we're not getting the filter plot that we want. So let's see if our updater is actually getting hit here. So okay, so you've got a bunch of stuff in there. So let's see. You've got all of our set cutoff parameters and whatnot. Okay, so I don't think we're ever actually calling this update filter plot path. So let's make sure that we do that. Yeah, let's give that a try. Where are we at here? Oh, okay. It's only 10:15 here, so we've got a nice long day ahead of us. All right. So now hopefully when we open the UI, we'll see some actual filter plots, and hopefully those will react correctly with the cutoff parameter changing. Interesting, maybe not. Oh, okay. So it looks like we do have something working. It's just not quite right, or it's not updating correctly. Yeah, so whenever I change this, it goes back to that flat line. Oh, that did something. Okay. Okay, so it must like reset the cutoff frequency or something whenever I change that. I think there's probably a reason for that. So, oh, and then it also is not updated correctly when we first create the component. So I'm going to do a little refactor here that I think will make this easier to do. So in order to do this, I'm going to need the parameters in this class. So we'll have our band splitter params here. I'll make them const. I think that'll be okay. And then I'll make a couple of functions. So we'll have update, update cutoff frequency. I don't think that's going to conflict with any names in the parent class. And then update filter type. Well, I'll do slope just to match the parameter name. I think that would be a little bit easier. It would help if I could spell that right. Cool. So I'll put these in some helper functions, and this will help kind of our giant nested lambda thingy that's going on up there. And just hopefully clean that up a little bit as well. So let's give this a try here. So in update cutoff frequency, we basically just want to do what we're doing here, right? Like we don't need to do too much else. We do need to actually have a name for cutoff param because we don't have our capture list anymore. I'll just use the arrow to call it get. Okay. And then in here, all I need to do is call update cutoff frequency. And I think that'll make that part of the code a little bit simpler as well. I don't love how it rearranged this initializer list. That's a little bit more difficult to read now. Maybe I can do it a little bit differently and make clean format be okay with it. Yeah, okay, good enough. And then I'm also going to need to rename this so I don't get a conflict. And then we'll initialize band splitter params with band split params. And I think that'll be okay. And now I just need to do a similar thing with this other listener here. So we'll just move all this stuff to this function. And then here again, I'll do band splitter params dot slope. And then we'll call get there. And I think that'll be easier. And then finally here, we just need to call update filter slope. And that'll be fine. And then what I'm going to do is I'm going to call update filter slope here so that when the component is constructed, it's constructed with the correct slopes. And then last thing I'll do is also update the frequency parameter in here because it seemed like that was not getting updated automatically. So let's do that. Yeah, unless there's something else that I can call to do it for me. Well, I don't think so. Yeah, that's fine. All right. So yeah, I think that'll end up working out a little bit nicer for us, hopefully. Cool, let's give it a try. All right. Okay, that looks good. Sweet. So now if we just move the cutoff frequency, we're good. If we change the filter slope, that seems to update. Oh, I'm moving the wrong parameter here. Yeah, if we move the cutoff frequency around, we're good. If we change the filter slope, we're good as well. All right, yeah, that seems to be working out pretty nice. So now I think what we need is a way to actually control the cutoff frequency from inside the plot. So kind of what I was thinking, I think I had seen this on a plugin somewhere like a little while ago. was just kind of a little bar here, and then we could drag around on the bar and use that to move everything. So yeah, I mean, I don't know. Let's see what we get if I try to do that. And I actually had something that's kind of similar that I was doing for the signal generator here. Where is it? No, not in there. Must have been in here. Yeah, okay. I called it dragging slider. I don't know if that's the best name for it, but that's okay. So yeah, let's see what we were doing in here. So we've got all of our normal slider stuff, no text box, and then yeah, okay. Interesting. Let's see, I think I have maybe a simpler way to do this. So let me think about this for a second. Okay, while I think about it, I'm gonna have a little, I'm gonna work on drawing a little thing to indicate where the where the cutoff frequency is. So yeah, let me just do, I don't know, like a semi-transparent color. Let's do gold. We'll make it like, I don't know, mostly transparent or something. And then let's see, so well, no, I want to get the X coordinate for frequency, and the frequency would be the cutoff frequency, right? So this will be, well, if I can spell it right, this will be const auto cutoff X, I'll say X chord. And then maybe what I'll do is I'll do well, let me think about this for a sec. So what I want to do is draw a little bar, and I want it to be kind of even no matter what. So maybe let's do this. Cutoff bar X start will be this times like 0.95 or something. And then end will be times 1.05. That's probably not going to look right at first, but we can figure out exactly what we want that to look like after we see it. So now what I'll do is fill rectangle, and we'll do our X and Y coordinates here. So cutoff bar X start 0, cutoff bar X end. Well, probably going to want like a width and a height. So maybe let's do this. So let's do rectangle. Use rectangle. And with positions, this will be like the top left. So we'll do cutoff bar X start in 0. Right. We probably need to make this an int, don't we? Yeah. Well, I'll just do these as ints up here. So this will be choose round to int. Let's round to int up there. So we've got X start. So let's see, we've got with position, we've got with right, with right, cutoff bar X end, and then with height, yeah, that's how you spell it. And I'll just say get height, so it'll be the full height of the component. So I don't want a comma there. Okay. Maybe that'll get us something like what we want. All right, let's give that a try. Oh, thanks, Bastion. Glad you like Chow Tape. I like it too, but I'm very biased, so maybe not the most accurate source. Anyway, so yeah, the idea here is that we'll have a little semi-transparent bar on the screen that will show us where the cutoff frequency is a little bit more obviously. All right, let's see if that'll work. Yeah, that looks about right. Maybe it's a little bit too narrow. Yeah, we can make that a little bit bigger. And let's see what happens. Does it stay the same size as we get bigger or smaller? Or as we go up or down the frequency spectrum? Looks like it does. Yeah, okay. Also, maybe we've got a little bit too much room at the end here. Maybe I can change that to be a little closer to the end of the range. So maybe let's make this like 18 or something. And then I'll make this a little bit more, a little bit more opaque. And then let's try doing things like this to make it a little bit thicker. So now what I'm thinking is, that I'll just make this entire component also be a slider. So let's make it a private slider. I think that'll be okay. Well, nah. Let's go public anyway. So then what we're going to want is, let's see. Then what we're going to want is an attachment. So this will be the slider attachment, right? So this will be the cutoff attachment here. So this will be attached to the cutoff parameter. And so the idea here is that you're going to just be able to drag around that little gold bar, and that will change the cutoff parameter. So let's see if we can get that to work. And splitter params cutoff. We're going to want a reference. We're going to want the plugin state, and I guess we're just going to want this because this is now the slider. Yeah, I don't know. This might get a little bit. Sort of too interconnected by making the plot a slider as well. So maybe I'll do that differently later, but I think it'll be okay. Yeah, okay, this isn't going to work because so equalizer, plot, and slider are both juice components. So now we've got what they call the diamond problem, where you've got like two classes that depend on each other internally. So maybe we'll do something different. Anyway, I'll keep thinking about that. So Jordy's got a question. Any specific videos you recommend for a first project? Would a reverb be doable? For a first project, I think there's a couple of videos from ADC for the last couple of years that had like sort of getting started with juice type of theme to them, and sort of helping you set up your project and things like that. So those might be a good place to start. The audio programmer has a number of sort of ways of getting started with either juice or there was some stuff more recently on Max MSP and things like that. So depending on what you want to do, the audio programmer's probably got a video that covers it in some respect. I'm not sure I'd recommend a reverb for a first project. Personally, I find reverb to be one of the harder effects to make. Yeah, I guess if you're interested in that, maybe starting with a delay would be good, and then you could build up to reverb from there, because a lot of reverbs have delay things happening internally. So maybe starting with a delay would be good. And even delay has a few kind of gotchas that are not always the easiest thing to do. But yeah, definitely I'd say start with a delay and then build up to reverb. And yeah, there's people who know more about reverb than me too, who would probably have better advice. But yeah. Oh, cool. Yeah, Wavemorpher has some suggestions on Dash Glitch and people doing reverbs in Bitwig. I should check that out. Yeah. Yeah, people who do like reverbs in things like the Bitwig grid and in VCV rack, like just from building up from like these lower level modules is super cool. I haven't followed up with that stuff enough, but there's some really cool videos out there showing like reverb effects from a more like building block view rather than like a code view. Yeah, I should look into that as well. Thanks, Wavemorpher. Anything you know about Faust compatibility with the latest Juice releases? I don't know anything specific to the latest Juice releases, but in general, I know that like Faust exporting to C++, there's like a lot of options and there's a lot of ways to do that. So if I were to use Faust, let's say in this plugin, probably what I would do is just generate, I forget the exact name of it, but there's a way to just generate like a generic C++ class. And then you would just need to hook up your Juice parameters to your Faust parameters and your audio buffer to your Faust like float pointers, and I think it would work out okay. But yeah, I haven't used Faust with Juice in a little while, so there's something that I'm not aware of that's changed. But that's okay. Things are always changing. Cool. So I think what I'm going to do here is make a different class for the slider. So this will be, I'll call it internal slider. Maybe that's not a great name, but you can change it later. And this will be a Juice slider. So yeah, I think I'm going to have this. I think I'm going to have this go underneath the plot, which probably means I'm going to need to change this to be like paint over children or something, or maybe have a second one. It's like paint over children. I always forget the name of it. Okay, that is the name. Cool. So let's do this. So and this will be paint over children. So yeah, the paint will just draw the background, and then paint over children will draw all the grid lines for us. And then I'll move this into the slider. But I have an idea for that. Oh, Wavemorpher is talking about, is it supposed to be Rinbo or RNBO? I haven't had to say it out loud before, so I guess now I have to make that decision. But yeah, RNBO looks super powerful. I haven't tried it out myself yet, but I definitely would be interested. Do you have experience on Traction Engine or Traction Graph? I have a bit of experience. I've worked with it at a couple of jobs that I've worked at in the past, and present actually. Yeah, it's I wouldn't say I'm an expert, but I've figured out a couple of things. There's still a few things that I don't fully understand yet, but that's probably just from lack of experience and you know, things that I'll learn about as I use it a bit more. Yeah, but yeah, traction is very powerful. Yeah, there's a lot you can do with it. But I think it also depends on like what kind of things you want to do. Like for a plugin like this, I'm not sure traction would really help that much. So yeah, I think you got to look at what traction offers and what you're trying to do and see if it fits. But yeah, they've got a lot of really cool stuff, and they're always updating it and supporting new things. So it's definitely a cool project and a great thing to learn from too, since it's the code is available. What am I programming in this stream? Yeah, so I guess I explained at the very beginning, but it's been a little while. So this is a new plugin that I'm working on called Chow Multi-Tool, and it's a bit different from some of my other plugins. So sort of the idea is that it's got a bunch of little DSP tools that I found useful for various things. So right now I'm working on a band splitter, and there's also going to be an equalizer and a signal generator and stuff like that. So yeah, hopefully it'll be useful for some folks. It's all very ugly right now, but that's how everything starts. So don't worry about it too much. And yeah, so right now I'm trying to get this UI for the band splitter up and running. So when we started today, this was just a blank screen basically, or actually it looked like this, where it was just the default UI. So now we've got some visualizers and stuff. So hopefully we can make this even a little bit better. Wave Mover says, I find that within Juice and Traction Engine and Graph, there are so many ways to make a sign os or create a signal chain. Feels a bit unclear what's canonical. Yeah, and I think, I mean, it's always sort of a tension I find within things like Juice and Traction, where you've got sort of this tension between having one clear way to do things and having flexibility to do things in different ways. So I think of it as like being opinionated or not being opinionated. So I think like in a lot of ways, for example, with Juice, like Juice isn't particularly opinionated on how you set up your audio graph. Like they give you a lot of different options and you can kind of pick which one works for you. Whereas maybe if it was more opinionated, then it would be more clear about, oh, this is the right way to do it. But then maybe if you needed more flexibility in the way you do your routing or whatever, then it would be, it wouldn't work as well. So maybe that's not true. Maybe there are some APIs that have a good balance between making it clear what's the easy way to do things and then also giving you lots of flexibility. But I think a lot of times you run into some tension there. Yeah, I mean, I don't know. I think usually what I do is just start with basic, like, here's a Juice audio buffer, and it's going to go through this plugin and then that plugin and then that plugin or Juice audio processor or whatever. And that ends up becoming my signal chain. And then if I need something more complicated, then I look at the Juice audio graph or some of the, maybe some of the ways that Traction is doing things with setting up like clip-based editing and track-based editing and things like that. But yeah, I find that usually, at least for my plugins, I don't really need that complicated of signal chains or things like that. So it ends up not working out. It ends up not being too complicated for me. Is Traction Graph ready for production? I mean, I think it is. Like you could use the Traction DAW, and I believe they're using the Traction Graph internally. So if it works in their DAW, then I'd imagine it works for whatever production level thing you're trying to do. But again, maybe also like if you're trying to do something that has routing that works in a very different way than in the Traction DAW, maybe it wouldn't fit exactly with what you're trying to do. But yeah, it just kind of depends on what you're trying to do and what Traction offers relative to that. But yeah, I mean, I think kind of the cool thing about Traction Engine to me is that you've always kind of got a proof of concept that it works, in the sense that you can just download Traction as a DAW and use it that way as well. So that's kind of a neat thing to do as well. But yeah, thanks for the questions, guys. This is fun. Drink some water here. Oh yeah, I'm hoping to do more streams as well. So yeah, Josh was kind enough to help me get set up and have me on the channel and everything. So yeah, I'm definitely hoping to do a few more, maybe in the next few weeks or so. Yeah, it just kind of depends on how much time I have. Like, I started working on this plugin maybe in December, and I just haven't had too much time to make a lot of progress on it. So maybe if I force myself to do these streams regularly, then I'll have to make time to work on it, which is nice in some ways as well. So yeah, that's always a nice, it's nice to have a deadline or people expecting something from you sometimes, because then it forces you to make time to work on things, especially if it's something that you really want to work on like this. So for internal slider, I'm gonna have a paint here. And then I'm gonna have a spelled this wrong. No, don't declare singleton. Okay. I'm going to have a getter function to get the thumb bounds. And this should be const. I think you'll see what this does in a second. I don't think I'll need a resized. And then probably I'll want a constructor. And then, I don't know, some people don't like this, but I'll just I'll just declare the variable here as well. I don't know, some people say that's bad style or something. I don't really have an opinion either way, so I can live with it. Okay, and then I'll need to define these functions in the CPP file. So let's reorganize this. Oh yeah, and then this, I'll need to have the attachment point to the cutoff slider. Cool. So internal slider. Oh, and this is inside band splitter plot, so I need to do it that way. All right. And then do a similar thing with these functions. And create the functions. So what I'm going to do in get thumb bounds is just do what I was doing here and get this. So okay, for this to work, I'm going to need a couple of things. I don't need the graphics thing. Return that. So this is just going to return the rectangle that we were drawing the little gold bar in. For this to work, I'm going to need the cutoff parameter, and I'm going to need a way to get the x coordinates. So I think what I'm going to do is have a float parameter reference. So this will be cutoff param. And then I'm also going to have a reference to this base class, and then I can use that to get the x coordinates and y coordinates. So I'll call this plot base. And then I'm going to need to get these from the constructor. So I'll put these as constructor arguments. I guess I don't need to, but I think that would be the cleanest way. So now let's put these in here. Make sure we don't have any naming conflicts. And let's see. We'll have a cutoff param coming from cutoff and plot base coming from plot. All right. Is there something we're missing? I don't think so. I'm also going to do this. I'm going to have the mouse cursor be a I think I'm going to do a left-right arrow cursor. I think that'll be cool. Anyway, we can fix that later. And so here we'll do, here, let's do this. So we want base get X coordinate, and this will just be cut off param, and we can do a dot instead of an arrow now. And then everything's happy there. And then all I need to do here is just take this bold business and put it up in the paint function here. And then fill rect like we were doing before. Fill rect, get thumb bounds. And then I think you'll see in a moment when I was doing this get thumb bounds separate function. Or at least, yeah, I hope you will, because I think it'll make things a little bit easier. And so now we'll do add and make visible cutoff slider. I think that'll work. Oh, and then I didn't initialize the cutoff slider, so let's do that. Cutoff slider. Same parameter here. And then I think this can just be this for the plot base. I think that'll work. All right, and then I feel like I'm missing something. What am I missing? Oh, right. Set text box style. No text box. And I don't think these arguments really matter that much. So this is just setting like the size of the text box and if it's read only or not. But we don't care about that here because there is no text box. And then also slider style. I think we're going to want this to be a horizontal slider. Linear horizontal. Is that the only argument we need in there? Yeah, I think that'll be okay. Let's see. And then there was one other thing I wanted to do, which was override hit test. So I don't remember off the top of my head how this works. So let's find out. There we go. All right. So the idea with hit test is that we can tell Juice if if a certain area, if the mouse is over a certain area of the screen, is that over our component or not? And the reason why I'm doing this is because I only want that to be true if the mouse is in the gold bar area that we're painting. I don't know if that'll actually be best for the user, but let's give it a try. I think that'll be cool. So we'll do return thumb bounds contains. Yeah, okay. And then I believe XY is relative to the component. Yeah, relative to the left and right hand or left and top edge of this component, guaranteed to be greater than or equal to 0. I think that'll be fine. Oh, and then I know what I'm forgetting. I need to also resize the slider. So the slider is going to be the same bounds as the plot. So that'll be fairly easy. So this will be slider, local bounds. All right. think we're ready to try this. Yeah, that's a good thing to do in the morning too. Just work on something fun and talk about it a little bit. I think at least for me, it helps me wake up a little and get my mind going early in the morning. So yeah, this has been good. All right, we're almost ready. If rig is ready. All right. Cool. Let's see what we've got. Okay, so we've got the slider. It looks like it's in the right spot. And then, yeah, it looks like we can drag on it. Cool. Yeah, I guess, okay. Yeah, so the only thing that's a little bit odd is, for one thing, well, yeah, it's the main thing that's odd is that the position of my mouse is not the position of the thumb. So I need to work out something a little bit different to do for that. Yeah, and then also, like, if I just put this at exactly 1,000 hertz, it's not perfectly centered with where the gold bar is. I'll think about that a little bit. So, oh, wrong way. 100 hertz. Yeah, it's not quite centered. Oh, okay, we've got some annoying comments here. I don't know how to get rid of those exactly, but maybe there's a way. Yeah, I'll figure that out for next time. Anyway, sorry about that, everyone. Yeah, if anyone does know how to make those go away, just let me know, because that would be helpful. Oh, okay, Wave Morpher has an actual question. Bit of a tricky question, but what part of your publicly available code do you find particularly noteworthy and complementary to Juice and Traction? That's a good question. So I guess there's kind of two parts of it. One is like the plugins themselves, which is like, I don't know, I guess for the most part, like Juice and Traction themselves don't make like publicly available plugins that are sort of more complicated than some of the simple examples that they use for their demonstrating how their libraries work, which makes sense. I mean, that's kind of I guess the idea of the examples is to demonstrate how the libraries work. And then the other part of it, I guess, is with my libraries and stuff. Like, I don't know, I feel like sort of the goal is a little bit different for most of it. So like, I guess probably you're mostly talking about this library, the ChowDSP utils library. Like, a lot of it is just kind of building on Juice stuff. Like pretty much everything in this plugin folder is just like, oh, these are extensions on the Juice parameter classes. And it's, you know, maybe things that are a little bit less general and are a little bit more specific to the kinds of things that I tend to do. A lot of it is just from noticing like patterns in how I write my Juice code, and saying, oh, I tend to use this pattern a lot. Let me just make a thing that encapsulates that pattern so I can reuse it more easily. Like plugin base is probably the best example of this. This is just Juice audio processor with like default overrides that I like, the default overrides that I usually use when I use Juice audio processor. And then some of it, like I was talking about ChowDSP version, like Juice only recently updated to C++ 17. So there were some things that I was able to do that were a little bit nicer than what Juice could do when Juice was compatible with C++ 14. And so, you know, I was able to take advantage of that. Some of it too is like bringing in third-party dependencies. Like I think I talked about this at some point before, how there's this Rocket library that I like a little bit better than the juice listener pattern. So I brought in this third-party library that I use instead. And then the rest of it is mostly just like DSP stuff, which like Juice has their DSP stuff, but like, for example, I don't think Juice would ever have like a modal modeling system in their DSP library just because it's a bit too specific and not really something that maybe most people would want. So I did that myself, and that's something that I use, maybe not a lot, but now and then. Or like this SIMD module is just like a wrapper on XSIMD, because I like that a little bit better than the Juice SIMD classes. But yeah, so it's just kind of a mix of things, really. And then yeah, what decides if it's GPL or BSD? A lot of times it is based on dependencies. So if I have a module that's like based on a third-party library, then I usually just go with whatever like is the most permissive license allowable by the third-party library. So with XMD, I think they're also BSD. So this module is BSD. I think with like, I think it's DSP utils. This has some of my delay classes. And there's a sync interpolation method that I borrowed from the Surge synthesizer. So that has to be GPL. Yeah, I think it's a little further down here. Yeah, so I borrowed some of this code from Surge, so it has to be GPL because of that. And just like things like that, that tend to sort of force the decision one way or another. And then some of it too is just like kind of arbitrary, like, well, this feels like it should be BSD. I try to make as much stuff BSD as I can, just because that makes it a little bit easier for other folks to use. But yeah, it's I don't know. It's not always like a very exact decision, if that makes sense. But yeah, so let me see if I can get this this gold bar worked out a little bit more nicely. So the problem is that we want the geometric mean to work out so that it's the yeah, we want the geometric mean to work out so that when these two numbers are multiplied and then you take the square root. Oh, what did I do? Okay, then when you do the geometric mean of these two numbers, you get 1. So let me maybe Wolfram Alpha is the best tool for this. So square root of so basically we want square root of x times y equals 1, right? But that's a little bit underspecified, right? Yeah, there's way too many solutions that kind of fit along here. So maybe if I do 0.9 on the lower end, then it can tell me what y should be. So 1 over 0.9 squared, basically. Okay, so let's do it this way. Let's just do some const expert stuff. So low malt will be 0.9. And then to get the high malt, it's going to end up being 1 over, it's going to be low malt squared. So I'll do, so this will be the square of low malt. And then this should be, like if I do over 0.9 squared, this should be what I want, right? No, okay, I did that wrong. Maybe it's just 1 over 0.9, right? Yeah, that's about right. Okay. Yeah, that should be right. Okay, so now it should be even on both sides. That'll be helpful. And then maybe I don't want to round it int immediately. I think I'll leave it for now. Oh, Wavemore was asking about Bitwig spectral splitting devices. I haven't actually tried them yet. I heard so much about them, and I just haven't gotten around to actually trying them. Actually, one thing I was thinking of for the Chow multi-tool would be a harmonic percussive splitter, kind of like what one of the new Bitwig devices has. But I haven't finished the DSP for that yet. Maybe that'll be a future stream. But yeah, it looks really cool. I just haven't tried it yet. And then maybe I'll make this a little wider. Yeah, I should do that today. Seems like they're super cool. Yeah, everyone I've talked to who's tried them seems to really like them, so I should do that. Yeah, so the other thing with the slider here that's bugging me is the X coordinate is not matching up with the value correctly. So let's see if I can get that to work. Yeah, I think what Bitwig's doing with the splitting devices and is it Eventide? I think that had split EQ and a couple of other plugins recently that are sort of based around that similar kind of idea. I think there's a lot of really interesting things that people are starting to do in that realm. So I think that's going to be super cool. Okay, set skew factor. I feel like that might be what I want. Yeah, I was hoping there'd be something like get X value. Okay, user-defined mapping of distance along the slider to its value. Value to proportion of length. This is probably what I want to override. Let's see what happens internally in Juice Slider when they do this. Modules. Is this in widgets? Yeah, okay. Value to proportion of length. Okay, so it does this norm range convert business. See, I thought that would get taken care of for us with the parameter attachment. Maybe not. Maybe it's hit test that's causing our problems. Well, yeah, let's just try this just to see what happens. What if I do return the base class implementation? Either way, yeah, I'm pretty excited with how this this band splitter UI has come together. Obviously, the design is kind of non-existent for now, but I think the basic ideas are there. So I think this will be pretty cool once we get it looking good. Cool. Okay. That looks pretty good. Yeah. Oh, interesting. The bars didn't show up until we started moving things. Okay, so we're still a little bit off. Interesting. Okay. Yeah. I wonder if that's because we've got a little bit of padding in the X direction between the start and end. of things. Okay, so let's try some things here. Yeah, and I wonder why these didn't draw until, well, really it was those that didn't draw. The red lines didn't draw until after we started moving things. Interesting. Maybe there's like a resized thing in here. Probably what we need to do. Yeah. Probably need to call the base class here. Resized. What's wrong here? Oh, equalizer plot. That was it. Yeah, I bet that's gonna help. Okay, and then what we want with the sliders is we want to override these methods. Internal slider. Right. Double proportion of length and value to proportion of length. All right, let's try that. So the value should be not like a normalized value, right? It should be a, yeah, value should be like the cutoff frequency value. So that'll be in units of hertz, right? So what we want is to do plot base get x coordinate for frequency, right? And then we want to, I guess we need this to be a better. And then this is going to return a float. So this is going to need to be a double as well. And then we'll divide by double get width, right? I think that's how we want to do it. What's wrong here? Oh, right. I'm casting the wrong way. This needs to go to float. Okay. All right. And then in here, we're going to want the opposite. So this is going to be base dot get frequency for x coordinate. And so x coordinate is going to be a float. So this is going to be float proportion times float get width, I guess. And then we're going to turn this as a double. Yeah, let's give that a try. I think that'll get us a bit closer to what we're looking for. We got a return statement here. Yeah, things are compiling a little more slowly than usual today. Probably because I'm running Zoom, yeah. Anyway, that's okay. More time to sit and think about things. That's not a bad thing. All right, so let's try this. All right, yeah, hopefully this will match up the coordinates in the way that we're looking for. Yeah, that looks pretty good. Yeah, I can live with that. Nice. Maybe I'm going to make the bounds a little bit shallower on that side. Yeah, because I think I like how close we get to the bounds on this side. So maybe I'll try to do the same thing over there. And then I don't know, maybe I should make the maybe I should make these a little bit thicker as well. That's probably okay. I can live with that. And then yeah, so maybe the only thing to change then is make this get a little bit closer to the end there. Let's try that. So those are in our plot params here. We'll go to 22 kilohertz. Yeah, okay. I think that's pretty close to where I wanted to get to today. Yeah, anyone have some ideas for how to make it look better? I haven't really thought about the design aesthetics at all, just trying to get things functional for now. Oh, I also wanted to check the filter slope. So 96. Okay, so that's a 12th order filter. Is that actually 96 dB per octave? 12th order filter. No, because 6 times 12 is 70. 6 times 12 is 72. So that's a 72 dB per octave filter. Okay, I'll just change the name to make it accurate on this side. Where are we? Over here. That means we want this to be 72. Wow, likes 18 dB. Yeah, I haven't done a 18 dB crossover filter. That tends to be a little bit tricky to get the reconstruction to line up right. I might have worked it out. I don't remember. But yeah, we're doing 12th order, so I'll just make that make the name be accurate, and that'll help. Oh yeah, what kind of processor am I coding? So this is right now this is a band splitter, but this plugin's gonna have a few other things in it as well. Close up some stuff that we don't need anymore. Yeah, so this is just how the actual DSP side is running. Basically, we've got first order filter, second order, fourth order, and so on. And then we just decide which one we want to run based on the parameter. I guess I could have done a switch case there, but for whatever reason, I felt like doing if else. That probably doesn't matter too much. I bet the code generation is going to be the same. And then we're doing process filter and a lambda up here. So we set the frequency and then we just process. Yeah, and I think that should be fine. Yeah, more or less. Anyway, let's give that a try. Yeah, now maybe we're a little bit too close to the end. Well, actually, I think we're okay. It'll look better once I get a couple more lines out on that side of the spectrum. Okay, yeah. So I'm happy with how this looks, and let's just make sure that I didn't break any of the functionality. So let's see here. If we just do low, then we've got just the low band. That seems to be working. And then let's do steeper slope. Yeah, that seems fine. Cool. Neat. All right. And then flip the flip thing to use the other side. Cool. Yeah, I think we're okay with that. All right. Oh yeah, so there's one other thing that I've kind of been pondering with this plugin, which is how I want to handle parameter modulation. Because in previous plugins, I'll just show this real quick. What I've done in some of my other plugins for parameter modulation is, well, let's do it here. That's not a good one to show it with. Yeah, so like with this one with parameter modulation, what I would do is just show in the slider. So the slider will show you sort of the modulated value. Oh, even that one's not a great one to show it with. Let me pick one with better colors. Let's see. Yeah, okay, this one's probably gonna be easy to see. Let's do classic LFO. Yeah, so you can see how the arc changes its value, whereas the pointer points to the same value when you're doing parameter modulation. And that's fine, but I'm a little concerned what's going to happen if I try to do that here. Because I can do the same thing, like you can probably tell if I get this working, like you can tell that the DSP is doing the right thing and it's doing the parameter modulation, but it's not showing up on the UI at all. I don't know if there's a way to make it show up without getting like super, like I can probably make the yellow bar move around, but then it would be tricky to actually move it while that's moving around. Maybe I make the red lines move around. I don't know. I'll keep thinking about that. There's probably some way to do that. Anyway. Cool. Yeah. So I think that's all I'm going to do today as far as coding. I'm pretty happy with how this is going. Yeah. Seems like sometimes the arrow cursors don't show up. Maybe that's okay. Yeah, not too big of a deal. Anyway. Yeah, I think I'm happy with this code for today. So I'm gonna push this to the repository and go from there. But yeah, if anyone's got any questions before I head out for the day, I'm happy to talk. I'm gonna call this thing the basic and explorer UI. Cool. Yeah. So if anyone's curious, in this plugin right now, it's on GitHub over here, Chow Multi-Tool. There's a little note here in the README that this is still very pre-alpha. So, you can use it if you want, but maybe don't do anything too crazy. Oh, I left my little notes to myself here. I'll get rid of those just so I don't forget about them later. Well, I should keep a note of these somewhere. That's fixed now. Oh, thanks, John. Yeah, glad you like the plugins. Yeah, I'll be doing more of these streams in the future. So if anyone's curious about what else I'm working on, maybe I'll show some other things as well. Yeah, I think this one's taking up most of my time right now, but I've got a few other little research ideas that are maybe gonna pop up sometime soon. Oh, I should spell GitHub right, not GitHub. Let's see. And then I'll make a little personal notes file. These there, and then I'll ignore those from Git. All right, yeah, so that's where we're at for today. Yeah, so oh, can't even spell read me right. Yeah, my typing is getting very my typing seems to be getting worse by the day. But yeah, so this is kind of what I've got in the multi-tool at the moment. Maybe I'll add a few more, like maybe I'll do a delay or something else in there. Brick wall filters is probably going to end up looking pretty similar to the band splitter that we were working on today. I thought about combining those actually, but it would probably be difficult because I wanted to have the brick wall filters include a few other filter types like Chevy-Chev filter and maybe an elliptic filter and stuff like that. And those can be difficult to do in like the idea with the band splitter was that you would get perfect reconstruction. And I'm not sure. I feel like that would be kind of difficult to do with the brick wall filters. So yeah, I think I'm going to keep those separate. And then for SVF, I have a couple ideas of things that'll be cool in there. And then yeah, everything else just needs a lot of UI work and other kind of fixes and little things like that. So yeah, I'm excited to see how this comes together. I think it'll like visually it will look a lot different from my prior plugins, and under the hood there's a lot of different things too as well, which maybe I'll talk about more in some future streams. But yeah, I'm pretty excited about it. I think it'll be a cool plugin. Hopefully people will like it, and even if not, I'm sure I'll use it. So that's really all I want from it. And then yeah, I'll have some more plugins coming up after that, which yeah, maybe we'll do some different streams and stuff to talk about those. But yeah, if anyone's curious, definitely get in touch on GitHub. You can do a GitHub issue or whatever you like to do. So yeah, I guess maybe I'll leave another minute or two for questions here in case anyone has other things they'd like me to talk about. But if not, I'll probably end the stream and maybe get some lunch or something. Set this back to something that works a little better for me. Yeah, maybe I'll try 16 instead of 14. Yeah, I'll give that a try. I guess you're going into a more GUI-centric direction with Chow multi-tool. Not necessarily. I think it's more that like a lot of the DSP stuff is things that I already kind of have code. Like a lot of the DSP stuff that's going to be in this plugin is stuff that I already kind of have code that does more or less what I want, just from like prior plugins that I've worked on or things that I've been experimenting with. So I'm trying to do some things a bit different with the GUI for this plugin. And so I'm spending a bit of time on trying to work out exactly how that's going to work. In particular, I kind of, and part of it's just like a challenge to myself. I'd kind of thought that maybe I should try to do a plugin that doesn't have any sliders. Like I think with EQ, we've kind of figured out a good way to be able to visualize the parameters and edit the parameters in the same kind of view. Like a lot of plugins like FabFilter and even like stock EQ plugins do this pretty well. And so I'm hoping to kind of go in that same direction with a lot of things that aren't EQ also. And hopefully that'll work. Okay, WaveMorpher wants me to talk about tuple helpers visit at. So I guess I'll show the code for that real quick first. So that's a little ways in here. Yeah, so I think this is, I either borrowed this from someone on Stack Overflow, or I saw something about how like maybe this is going to be in a future, like in a future version of C++ or something. I don't remember exactly, but it was kind of inspired by if you've ever used STD variant. So with STD variant, basically the way it works is you create a variant that could be one of, some different types. So it could be an int or it could be a float or whatever. And then one way of getting the actual thing or doing something with the actual thing in the variant is using this thing called visit. And it works pretty well, but it's C++ 17 and later. And even with C++ 17, there are some versions of Clang and GCC that don't really support it all that well. So it can be a little bit tricky to use in production code. But the idea here was kind of to be something similar, where basically you say, okay, I want to do something to the third element in this tuple. And so then what you can do is you can call visit at, and it will basically use this template function to call that thing on a particular thing in the tuple. And then, yeah, the way that it works internally is through a little bit of template recursion. So you've got visit impl for index I, and then you go all the way down to index 0. And then at that point, you are done, I guess. Why is it used for setting up oscillators? Yeah, so this was something that I've been trying to do with this plugin that I don't really know. I don't really know if it's a good idea, but again, it was just something that I wanted to try. So the idea was that I would try to have as many things in this plugin happen at compile time rather than at runtime. And so the way that works with the oscillators is I've got all of these oscillators, and they're all here in this tuple. And so kind of the neat thing about using visit at for interacting with them is that I can, basically what this means is that this is sort of a compile time if statement to let me choose which of the oscillators I'm going to work with. Maybe that's not maybe that's not exactly a good way to describe it. I don't know. I'm not being exact. I'm not being very precise with this description. So I don't know. Someone in the C++ standards committee would probably not be happy with this explanation, but I guess that's what I've got for now. I thought a tuple was just two things. Oh no, so that's a STD pair. So a tuple could be as many things as you want. It's basically like, I don't know, tuple is basically equivalent to, let's say, struct tuple, and then I would have like thing one, and then thing two, right, and so on. Except it's just in this container here, and you can make it templated and all that. So yeah, so in this case, I have all the oscillators in this tuple, and then using visit at basically lets me choose which thing I want to work with at a given time using the oscillator choice parameter. So I don't know, maybe it's making the code worse rather than better, but I don't know. Yeah, so I guess like another way that I could have done this would be to have like a base oscillator struct, and then or a class, right? And then have like not typing very well here. Struct sign oscillator, inherit the base oscillator, and then have everything work that way. But I didn't really want to do polymorphism here, so I figured I'd do this tuple thing instead. So it's kind of just a different data type instead of std vector owned array. Yeah, and I guess what makes tuple a little bit different from those things is it's like std vector, you can add things to it at runtime, whereas with tuple, it's fixed at compile time. You can't add another thing to the tuple. I guess in a sense, it's more like a standard array, except that array has to be multiple things of the same type, whereas a tuple can be things of varying types. Yeah, so that was my way of doing this. I don't know if it's the best way, but it was something different. So I wanted to try something a little different. And yeah, maybe I'll change it later and make it more simple or something. But yeah, that's what I've been doing for now. Anyway, yeah, I think I should probably call it a day here and refill my water and get some lunch and stuff. But yeah, thanks for everyone who tuned in. I had a lot of fun, and thanks again to Josh and everyone at the audio programmer for having me on. And yeah, I'm sure I'll be doing more in the future, so I'll be sure to let Josh and everyone know. But yeah, I had a lot of fun, so thanks for tuning in. and hopefully I'll see you in a future live stream. Okay, oh, there we go, end stream.